Good morning, all. Welcome to the lecture of measure and integration. Am I audible?
Yes, sir.
Yes, sir. Good.
Okay, so in last lecture we have started a new point which is nothing but the outer measure, and we have seen the definition of outer measure. Any function mu star which is defined from power set of x, where x be any set to whose codomain will be close to 0 infinity union infinity, and if it holds the three properties, that is mu star of 5 will be equal to 0, mu star is monotonic, and mu star is countably additive, then we say that the corresponding function mu star is a outer measure. Okay, after that we have proved over the result. The collection curly b of mu star measurable sets is it forms a sigma algebra. Okay, now let us see one example. Assume that I is a sequence of disjoint measurable sets and let capital E is nothing but union over I running from 1 to infinity EI. Then for any set capital A, then for any set capital A, we have outer measure of sorry yes outer measure of A intersection E is nothing but summation I running from 1 to infinity outer measure of A intersection. Okay, so here we have given one sequence EI, which is a sequence of disjoint measurable sets. That is, it is the collection of just a measurable sets, and they are disjoint. That is, EI intersection EJ will be equal to 5 whenever I is not equal to J. And also we have given that capital E is a set which is a countable union of these disjoint measurable sets. And from this one, we have to prove that outer measure of A intersection E is nothing but the summation I running from 1 to infinity outer measure of A intersection EI whenever EI are disjoint measurable sets. Okay, see its solution. Here EI is a sequence of disjoint measurable sets and E be a set which is nothing but union over I running from 1 to infinity EI. Okay, which implies A intersection E is nothing but A intersection union over I running from 1 to infinity EI. But there is no term of I in A. Okay, so it can be written as union over I running from 1 to infinity A intersection. Yeah. So A intersection E is nothing but summation union I running from 1 to infinity A intersection here. Okay, as we know that outer measure is countably subadditive, so by that property we get outer measure of A intersection E is less equal by summation I running from 1 to infinity outer measure of A intersection E. But again there is one property. If EI be a sequence of disjoint measurable sets, then outer measure will be a countably additive. See, that is outer measure will be countably additive on the disjoint collection. As here EI is a disjoint collection, then A intersection A1, A intersection A2 up to so on, A intersection whatever it will be. They are all disjoint. Therefore, here there is no need to go to prove its converse inequality. That is, as it is true for outer measure of A intersection less equal and outer measure of A intersection is greater equal of. That is we have to prove. But we have given EI be a collection of disjoint measurable sets, and on disjoint collection outer measure will be countably measure is countably additive. Okay, so obviously the result will be true. That is outer measure of A intersection is nothing but the summation I running from 1 to infinity outer measure of A intersection EI. But there is one way to prove its converse part also. Let us see whatever. As here EI be a collection of disjoint measurable sets. It means E1, E2, or E3 up to so on all are measurable sets. Let us take E1 be measurable set. E1 be measurable. Since which is given, as E1 is measurable, then it holds its property. That is any set E is said to be measurable. Whenever for any set capital A, we have outer measure of A is nothing but outer measure of A intersection E plus outer measure of A intersection E complement. As here E1 is measurable, then we can write it as outer measure of one set. Take that set as A intersection E1 union E2, and here our E1 is measurable intersection, sorry, so it is equal to outer measure of A intersection E1 union E2 intersection E1 plus outer measure of A intersection E1 union E2 intersection E1 complement, which is just by the definition of measurable set. As E1 is measurable, then we can write it as in this form. And we know that if E is measurable, that is E be any set, then outer measure of E is always less equal by outer measure of A intersection E plus outer measure of A intersection E complement. And if we prove its converse part, then the corresponding set will E will be measurable. As E1 is measurable, then outer measure of this A intersection E1 union E2 must be greater equal by outer measure of A intersection E1 union E2 intersection E1 plus outer measure of A intersection E1 union E2 intersection E1 complement. Now let us see. Now here E1 and E2 are two disjoint sets. Okay. Now therefore there are two possibilities for this E1 and E2. If suppose there is suppose we don't know whether this E1 and E2 are disjoint. If possible, suppose that E1 is a subset of E2. If E1 is a subset of E2, then E1 union E2 will be E2 and E2 intersection E1. As E1 is a subset, therefore it is nothing but E1. Okay. Similarly, there is another possibility which is E2 is a subset of E1. If E2 is a subset of E1, then E1 union E2 is nothing but E1, and E1 intersection E1 is nothing but E1. Okay. So these are the possibilities, and if they are disjoint, then it must be equal to empty. Okay. So it is nothing but outer measure of E1. Since if E1 is subset of E2, then also it is E1, and if E2 is subset of E1, then this E1 union E2 intersection E1 will be E1. Similarly, this will be as here E1 complement. Okay, so this one is nothing but outer measure of, sorry, A intersection E1 plus outer measure of A intersection E2. Okay, so here outer measure of A intersection E1 union E2 is greater equal by outer measure of A intersection E1 plus outer measure of A intersection E2. Okay, which is for two sets. If we consider these as only one set, then similarly if we take E3, and again which is true for this set also. Okay, so it is true for any finite number of sets, which implies outer measure of A intersection union over I running from 1 to n EI is greater equal by summation I running from 1 to n outer measure of A intersection EI. Okay, now just we apply the mathematical induction on it. If it is true for n equal to 1, and we will assume that it is true for some n equal to n equal to k, and if we prove it is true for n equal to k plus 1, then we say that it is true for any value of n. So it is true for these values. Then by mathematical induction we can take this n as tending to infinity. Then we get outer measure of A intersection union over I running from 1 to infinity EI is greater equal by summation I running from 1 to infinity outer measure of A intersection EI. So here we get the converse part of this statement. So now comparing these two, this one and this two, from 1 and 2, outer measure of, but first here write the value of union over I running from 1 to infinity I. Union over I running from 1 to infinity I is nothing but the outer measure of E. So it is nothing but A intersection E, and which is greater equal by summation I running from 1 to infinity outer measure of A intersection E. Now from 1 and 2 both are same, which implies outer measure of A intersection E is nothing but the summation I running from 1 to infinity outer sorry. There is a small mistake. Instead of mu I have written m. Okay. Just replace this with m by mu. Okay. Which is nothing but outer measure of A intersection EI. Whenever EI be a sequence of disjoint measurable sets, and that is we have to. Actually, here there is no need to prove this second part, since here we have given EI be a sequence of disjoint measurable sets, and if it is a sequence of disjoint measurable sets, then outer measure will be countably additive. Okay, from that only the result will be obviously true. Okay, any doubt?
No,
No,
sir.
sir.
Okay. Now there is one definition. Measure on an algebra. That will be the new concept. Actually, we have defined a measure on sigma algebra. Now we have to define a function which is defined on algebra, and that is said to be measure if it holds some properties. Okay, मेजरची डेफिनेशन आपण सुरुवातीलाच पाहिली. काय होती ती मेजरची डेफिनेशन? कॅपिटल एक्स कर्ली बी हा जर मेजरेबल स्पेस असेल तर म्यू हा एक फंक्शन आपण डिफाइन केला होता, कोणावर? सिग्मा अल्जेब्रावर डिफाइन केला होता. इथे इन्स्टेड ऑफ सिग्मा अल्जेब्रा तुम्हाला डिफाइन करायचा आहे अल्जेब्रावर, आणि त्याचे काही कंडिशन असतील. जर ते होल्ड झाले तर आपण करस्पॉन्डिंग फंक्शनला काय म्हणणार आहे? मेजर म्हणणार आहे. कोणावर? दिलेल्या करस्पॉन्डिंग अल्जेब्रावर. ओके, let curly A be any algebra. The function mu, which is different, as we have to see the definition of measure on an algebra, that is we have to define the function on algebra. So its domain will be curly A, and codomain will be closed to 0 infinity union infinity, and is said to be is a measure on an algebra curly A, algebra curly A if first one measure of empty set will be equal to 0, and second one if AI be a sequence of disjoint sets in curly A such that union over I running from 1 to infinity AI is belonging to curly A, then measure of union over I running from 1 to infinity AI is equal to summation I running from 1 to infinity measure of AI. Okay, so here let us see what is the definition of measure on an algebra A. That is a measure that is a function which is defined on a algebra curly A is said to be a measure on that algebra if it holds two properties, that is measure of phi will be equal to 0, that is mu of phi will be equal to 0, and if AI be a sequence of disjoint sets in algebra curly A with union over I running from 1 to infinity AI, which is belonging to curly. That is, if we take a disjoint sequence of sets in curly A, then its countable union is again in that curly A. Then we have to prove that measure of union over I running from 1 to infinity AI is equal to summation over I running from 1 to infinity measure of AI. Okay, डेफिनेशन क्लियर आहे का? मेजर जो की डिफाइन केला होता सिग्मा अल्जेब्रा, आणखी मेजर जो डिफाइन केला अल्जेब्रा, यामध्ये दोन्हीमध्ये काय फरक आहे कळते का? सेमच आहेत दोन्ही. ही डेफिनेशन आणखी तिकडची मेजरची डेफिनेशन दोन्ही सेम होते का? आवाज येते ना?
Yes, sir.
हा, दोन कन्सेप्ट वेगळे आहेत का दोन्ही सेमच आहेत? तिकडं फक्त अल्जेब्राच्या ऐवजी सिग्मा अल्जेब्रा केला होता, इथं अल्जेब्रा घेतला. मग डेफिनेशन मध्ये फरक आहे का? हे जो अल्जेब्रा तुम्ही घेतलाय हा सिग्मा अल्जेब्रा पण आहे. क्वेश्चन तर कळते ना मला काय विचारायचंय?
सर फक्त डोमेन चेंज केलं ना, बाकी प्रॉपर्टीज सेम आहेत दोन्ही.
बाकीचं सेम आहे तेच म्हणालो. मग त्याच्यामध्ये याच्यामध्ये काय फरक आहे? तिथं सिग्मा अल्जेब्रा होता, इथं अल्जेब्रा दिलाय तुम्हाला. मग हा अल्जेब्रा जो दिलाय हा सिग्मा अल्जेब्रा पण आहे का? नाही, असं नाहीये ना. प्रत्येक अल्जेब्रा सिग्मा अल्जेब्रा असू शकत नाही, पण काही प्रत्येक सिग्मा अल्जेब्रा तर अल्जेब्रा आहे. म्हणजे हा दिलेला अल्जेब्रा हा सिग्मा अल्जेब्रा आहे का? कारण इथं परत तुम्ही डिफाईन केलाय युनियन ओव्हर आय रनिंग फ्रॉम 1 to infinity AI बिलॉंग्स टू करली ए, म्हणजे हा काउंटेबल युनियनच्या अंडर क्लोज झाल्यासारखं आहे ना. हा अल्जेब्रा सिग्मा अल्जेब्रा आहे का? काय तर सांगा हो, चुकलं तरी चुकलं, काय प्रॉब्लेम? फक्त एवढंच सांगा मला, हा जो दिलेला करली आहे हा सिग्मा अल्जेब्रा आहे का नाही? अल्जेब्रा तर आहे, ठीक आहे. काही अल्जेब्रा असे असू शकतात ना जे सिग्मा अल्जेब्रा असतील. हा अल्जेब्रा सिग्मा अल्जेब्रा आहे का?
येस सर.
कशावरून? तो अल्जेब्रा आहे, सिग्मा अल्जेब्रा आहे का नाही 100% कसं सांगू शकणार तुम्ही? फक्त डेफिनेशन काय सांगते याची, या मेजर ऑन एन अल्जेब्रा म्हणजे जो एखादा फंक्शन तुम्ही अल्जेब्रावर डिफाईन केलं त्याची डेफिनेशन काय आहे? एक फंक्शन मी न्यू डिफाईन करणार आहे, कशावर? अल्जेब्रावर डिफाईन केलं, ज्याची रेंज ही आहे, सॉरी रेंज म्हणजे कोडोमेन हा आहे, काही व्हॅल्यू येतील यामध्ये. ओके. आणखीन हा मेजर होईल अल्जेब्रा ए वर कधी? जर मेजर ऑफ 5 विल बी इक्वल टू 0. ए आय बी अ सिक्वेन्स ऑफ डिजॉइंट सेट्स इन करली. हा ए आय बी जस्ट इट इज अ सिक्वेन्स ऑफ डिजॉइंट सेट्स. पण तिकडे सिग्मा अल्जेब्रामध्ये काय होतं? तुमचा डोमेनच सिग्मा अल्जेब्रा असल्यामुळे त्यात तुम्ही घेतलेले एलिमेंट कुठून घेणार? डोमेन मधून घेणार. डोमेन तुमचा सिग्मा अल्जेब्रा आहे आणि सिग्मा अल्जेब्राचा प्रत्येक एलिमेंट हा मेजरेबल सेट असतो. म्हणून तिथं काय होतं, तुमची सिक्वेन्स ही डिजॉइंट मेजरेबल सेट होती ती, आणि ही कंडिशन तिथं डिफाईन करायची गरज नव्हती. ही कंडिशन तिथे सांगायची गरज होती का तुम्हाला सिग्मा अल्जेब्रा असल्यामुळे? कारण सिग्मा अल्जेब्रा आहे याचा अर्थ तो ऑब्विसली क्लोज अंडर काउंटेबल युनियन आहे, म्हणून ही गोष्ट तिथे सांगायची गरज नव्हती. इथं तुमचं काय आहे? अल्जेब्रा आहे. हा क्लोज आहे अंडर काउंटेबल युनियन की नाही मला माहित नाही. म्हणजे जर एखादा डिजॉइंट कलेक्शन जर मला मिळत असेल, पण तो ही कंडिशन ही होल्ड केला पाहिजे, त्याचा काउंटेबल युनियन ही त्यातच जर येत असेल तर मला ही प्रॉपर्टी चेक करायची, अदरवाईज आहे. ठीक आहे.
येस सर.
एक सिक्वेन्स मी घेणार, करली ए मधून एक डिजॉइंट सिक्वेन्स घेणार, पण मी डायरेक्ट त्याच्यावर मेजर अप्लाय करू शकत नाही, कारण अल्जेब्रा असल्यामुळे तुम्हाला क्लोज अंडर काउंटेबल युनियन आहे का नाही माहित नाही. म्हणून ते जी सिक्वेन्स तुम्ही कलेक्ट केली तो ही कंडिशन ही सॅटिस्फाय केली पाहिजे, म्हणजे तो क्लोज अंडर काउंटेबल युनियन पाहिजे. जर तो क्लोज अंडर काउंटेबल युनियन असेल तर ही प्रॉपर्टी आपण चेक करणार, अदरवाईज. ठीक आहे. सो दिस विल बी नथिंग बट द मेजर डेफिनेशन ऑफ मेजर ऑन एन अल्जेब्रा. Now there is one theorem. Let capital A is belonging to algebra curly A and AI be a sequence of sets in algebra A such that A is subset of union over I running from 1 to infinity AI, then we have to show that measure of A is less equal by summation I running from 1 to infinity measure of A. Okay, so here we have given one set capital A which is a member of algebra curly A, and AI be a sequence of sets in algebra curly A, and we have also given that this capital A is a subset of union over I running from 1 to infinity AI, and from that we have to show that measure of A is less equal by summation I running from 1 to infinity measure of A. See its proof. But A intersection an intersection an minus 1 complement intersection an minus 2 complement intersection up to so on a1 complement. Now, as bn is a set which is nothing but a intersection an minus 1 complement intersection an minus 2 complement up to so on intersection of a1 complement. From this one, we clearly say that as bn is the intersection of these sets, then bn must be a subset of each of these sets, which implies bn is subset of an and each of these set a a1 a2 up to so on an all are the members of curly A, and bn is a intersection of all these sets. Therefore, it must be bn is also a member of curly A, belonging to curly A. Since a1 a2 up to so on an minus 1 all the members of curly A, curly A is a algebra. As it is algebra, then it must be closed under complementation. Therefore, complement of all these sets will be belonging to curly A, and A and An are also the members of curly A, and Bn is an intersection of all these combinations. Okay, so by construction of Bn must be a member of algebra curly A. So Bn is a subset of An and Bn is belonging to curly A. Now, what is B1 then? B1 is nothing but याच्यावरून B1 काय येईल? Bn is nothing but A intersection An intersection A minus 1 complement up to so on A1 complement. Then what is B1? A intersection A1 intersection A1 minus 1 complement, but A0 is not defined. Then B1 is nothing but A intersection A1. So B2 is equal to A intersection A2 intersection A1 complement. What is B3 then? A intersection A3 intersection A1 complement intersection A2 complement. Now, whether these BNs are disjoint or not, हा प्रत्येक BN disjoint आहे का? disjoint set म्हणजे कळतंय ना तुम्हाला?
Yes, sir.
मग ते B1 B2 B3 वरून तर सांगा ना. डायरेक्ट BN वरून कळत नाही म्हणून आपण B1 B2 3 फाइंड आउट की B1 B2 B3 फाइंड आउट केलाय. B1 B2 B3 वरून सांगा मला B1 B2 B3 डिसजॉइंट आहेत एकमेकांची का कोणतरी कोणाचा सबसेट आहे?
Disjoint आहे सर.
डिसजॉइंट आहेत ना. B1 काय आहे? B1 मध्ये एलिमेंट कोणाचे आहेत? A1 चे आहेत. B2 च्या कन्स्ट्रक्शन वरून काय कळतं? याच्यामध्ये A1 कॉम्प्लिमेंटचे एलिमेंट आहेत. A1 आणि A1 कॉम्प्लिमेंट मध्ये काही कॉमन येऊ शकतं का? नाही. सो B1 B2 disjoint झाले. Similarly B2 B3 disjoint. Okay, so here for each m not equal to n, bm intersection bn is equal to 5. That is bn is a disjoint, which implies bn is a sequence of disjoint sets in curly A, since each bn is belonging to curly A. Therefore, this sequence bn is a sequence of disjoint sets in curly A such that our capital A is nothing but union over n running from 1 to infinity bn. Okay, we will see this how this A will be equal to union over n running from 1 to infinity b1. Okay, so we'll check by using only b1 and b2. Okay, let us check the union of b1 and b2. b1 union b2, which is equal to b1 is nothing but A intersection a1 union A intersection a1 sorry a2 intersection a1 complement intersection a1 complement. So which is nothing but A intersection a1 union capital A intersection A intersection A1 union A2 intersection A1 union A1 complement. Okay, so actually this is now can be written as A union A, first bracket is nothing but A union A intersection A1 union A. Okay, so this will be the first bracket intersection A union A2 intersection A1 union A2 intersection A union A1 complement intersection A1 union A1 complement. दोघांच्या इंटरसेक्शन मध्ये मला शेवटी कॉमन काय मिळेल, यामध्ये A1 हे A आहे आणि A माझा जो दिलेला आहे तो सबसेट कुणाचा आहे, युनियन ओव्हर एन रनिंग फ्रॉम 1 टू इन्फिनिटी A आहे. म्हणजे काही काय A1 A2 असेल ना त्याचा सबसेट हा माझा A आहे. याच्यावरून या दोघांमध्ये पहिल्या दोन टर्म मध्ये A1 युनियन A इंटरसेक्शन A युनियन A सगळं इथं काय माझी फर्स्ट टर्म A आली, याच्यामध्ये E आहे. टोटल दोघांच्या इंटरसेक्शन मध्ये मला कॉमन काय मिळेल, A मिळेल. हा ए इंटरसेक्शन. आता सिमिलरली A युनियन A2 आहे, A1 युनियन A2 आहे, बट A इज अ सबसेट ऑफ A1 युनियन A2. Therefore again in intersection we get common term will be A. Since तिथं तुम्हाला A युनियन A2 आणखी A1 युनियन A2, A1 युनियन A2 चा सबसेट A आहे, पण A युनियन A2 इंटरसेक्शन A1 युनियन A2 आहे. त्याच्यामध्ये एक तर तुम्हाला A मिळेल किंवा A पेक्षा थोडेसे जास्त एलिमेंट असलेला कोणता तरी सबसेट मिळेल. पण शेवटी याचं इंटरसेक्शन कोणाशी होणार आहे, ह्या A शी होणार आहे आणि प्रत्येक मधून तुम्हाला A तरी मिळेल किंवा A पेक्षा A सबसेट असलेला काहीतरी सेट मिळेल. पण शेवटी त्या सगळ्यांचं मिळून इंटरसेक्शन ह्या पहिल्या A सोबत होणार आहे. तर टोटल इंटरसेक्शन मला काय मिळेल, कॅपिटल A मिळेल.
Yes, sir.
Okay, so B1 union B2 is nothing but A. Similarly, we can prove B1 union B2 union B3 is also A. So A is nothing but union over n running from 1 to infinity Bn. So now measure of A is nothing but measure of union over n running from 1 to infinity Bn, which is nothing but as each Bn is a sequence of it is a sequence of disjoint sets in algebra curly A. Therefore, it holds the countable additive property, which is nothing but summation n running from 1 to infinity measure of Bn, which is from the definition of mu. From definition of mu. But each Bn is a subset of capital An. Therefore, measure of Bn is less equal by measure of An for each value of n. Therefore, summation n running from 1 to infinity measure of Bn is less equal by summation n running from 1 to infinity measure of An, which implies which is less equal by summation n running from 1 to infinity measure of An. Since each An is a each Bn is a subset of An. An for all An. Okay, so here we get measure of A is less equal by summation n running from 1 to infinity measure of Bn. That is, it can be written as measure of A is less equal by summation I running from 1 to infinity. Sorry, here we have to take AI, and that is way how to, and here is the required result. Okay, तुम्हाला काही डाऊट यामध्ये?
No, sir.
काही नाही, एक सेट दिला होता A जो की अल्जेब्राचा मेंबर होता, आणखीन एक सिक्वेन्स दिली होती, त्यातला प्रत्येक मेंबर हा अल्जेब्राचा मेंबर होता. आणखीन जो A आपण सुरुवातीला घेतला होता तो सबसेट होता काउंटेबल युनियन AI चा. तर आपल्याला प्रूव्ह काय करायचं होतं, मेजर ऑफ A इज लेस इक्वल बाय समेशन ओव्हर I रनिंग फ्रॉम 1 टू मेजर ऑफ A, and for that we have constructed one set Bn which is nothing but A intersection An intersection An minus 1 complement up to so on A1 complement, and from that one we get measure of A is less equal by summation I running from 1 to infinity measure of A, and which is our required result. Now the next definition. Outer measure induced by a major. Okay, that is outer major, our mu star induced by a major sum. That is the new concept. ओके, आउटर मेजर डिफाईन करण्यासाठी मला एखाद्या मेजरचा यूज करायचा आहे. त्यासाठी सुरुवातीला मला एक मेजर घ्यावं लागेल. ती मी मेजर घेणार, मेजर घेऊन मी एक नवीन फंक्शन न्यू स्टार डिफाईन करणार कशा एखाद्या डोमेनवर. आणखीन तो त्यापासून तयार झालेला जो माझा फंक्शन असेल तो माझा आउटर मेजर इंड्युस्ड बाय मेजर. इफ इट होल्ड्स द प्रॉपर्टीज ऑफ आउटर मेजर. So let mu be a major on an algebra taken mu be a major which is defined on an algebra curly where curly is a subset of x. Now define, as we have to define mu star as outer major, then its domain will be power set of x. So define mu star from power set of x to closed zero infinity union infinity by outer measure of any set E is equal to infimum of summation I running from 1 to infinity measure of AI, where infimum runs over the sequence AI of sets in curly A such that our E is subset of union over I running from 1 to infinity. Yeah. So which is the definition of outer major which is induced by a major. Okay, and it's so mu star is called outer major which is induced by a major mu. So for that we have taken one major mu which is defined on algebra curly A, and we have defined one function mu star which is from power set of x to close the zero infinity union infinity, and which is defined by mu star of E will be equal to infimum of summation I running from 1 to infinity mu of AI, where infimum runs over the sequence AI of sets in curly. Infimum कुठे रन होणार आहे, या कलेक्शन वर रन होणार आहे, such that E is a subset of countable union of these sets. Okay, actually we have seen this type of definition in real analysis. Since we have defined outer major concept, then we have taken the open bounded intervals. Okay, that is union over n running from 1 to infinity in, and outer measure of the set A is nothing but the infimum of summation n running from 1 to infinity length of in. There we have taken length of in. So here instead of length we have to use the measure of these sets A, and remaining part will be as it is. Okay, is there is any doubt in definition?
No, sir.
रिअल अनालिसिस मध्ये जे आउटर मेजर डिफाईन केलं होतं आपण तिथं फक्त ओपन बाउंडेड इंटरवलचा यूज केला होता. त्यावर आपण समेशन रन करून इन्फिमम घेत होतो आणि त्याच्यावरून आपल्याला करस्पॉन्डिंग सेटचा आउटर मेजर मिळत होता. इथं फक्त लेंथ ऑफ इंटरवलच्या ऐवजी मेजर, कारण तुमच्याकडे मेजर ही कन्सेप्ट डिफाईन नव्हती. आता आपण त्याचं जनरलायझेशन केलंय, आणखी मेजर आपण डिफाईन केलंय, अल्जेब्राच्या एलिमेंटवर आपण मेजर डिफाईन केलंय, ती गोष्ट आपल्याकडे आहे. सो फक्त तिकडे आउटर मेजर आपण कधी यूज करू शकत होतो जर एखाद्या सेटला काउंटेबल युनियन ऑफ ओपन इंटरवलच्या फॉर्म मध्ये लिहिता येत असेल तर. पण आता असा कोणताही जर सेट असेल ज्याचा मेजर मला काढता येत आला तर मी त्याचा करस्पॉन्डिंग सेट ई चा आउटर मेजर काढू शकतो. ओके, बाय युजिंग द मेजर ऑफ दॅट सेट्स. So this will be the outer major mu star which is induced by a major mu. That is, this will be a new concept. Now we have to prove that this outer major mu star which is induced by a major mu is a outer major. Okay, that is, it holds the all the properties of outer major. See, set function, there is one result. The set function mu star is an outer major, And we know the definition of outer measure. If it holds the three properties, then it is outer measure. Since this function mu star has already the domain power set of x, so we have to check only three conditions. That is, mu star of 5 will be equal to 0, mu star is monotonic, and mu star is countably additive. See the proof. As outer measure of any set E is nothing but infimum of summation I running from 1 to infinity measure of AI, where infimum runs over all the sequences AI of set से algebra कर लिए, such that E is a subset of union over I running from 1 to infinity AI. Okay, so if by definition itself, if we take mu star of a phi, then which is obviously less equal by measure of phi, since infimum of this one is nothing but this one. So this one is already less equal by this one, since it is equal to infimum. Okay, so outer measure of phi must be less equal by this measure of phi, but measure mu is a measure. As it is a measure, then mu of phi will be equal to 0. So from this one, mu star of phi will be equal to 0. Now mu star of E is nothing but infimum of summation I running from 1 to infinity measure of AI, where E is a subset of union over I running from 1 to infinity AI. So from this one, but mu is a measure. As it is a measure, then it is monotonic, and as it is monotonic, then the corresponding function mu star is also monotonic. And real to also we have proved that if A is a subset of B, then mu star of A is less equal by mu star of B. That is, it is a monotonic, and there we have used the infimum. Okay, the infimum of length of IN. So from that one, this function is also a monotonic function. So clearly, as mu is monotonic, if A is a subset of B, then mu star A is less equal by mu star A. Now, let capital E be a collection of EIs. Let capital E is equal to union over I running from 1 to infinity EI. Okay. Now, if possible, suppose that there is one set EI having measure will be infinite. Okay. Since there are two possibilities, either each EI has a measure finite, or there exists one EI for having measure will be infinite. Okay. So, if measure of EI, sorry, outer measure of EI equal to infinite for some I, which implies summation over I running from 1 to infinity mu star of EI equal to finite, since there exists one EI having measure will be infinite. Okay, so summation I running from mu star of EI will be equal to infinite, and E is nothing but this one. It means E is a subset of this one. Therefore, measure of E obviously less equal by this one, which implies E is less equal by summation I running from 1 to infinity mu star of EI. This is for the first possibility. That is, if there exists one EI having measure will be infinite. So now second, if mu star of EI is not equal to infinity for all I, it means each EI has a finite measure. Okay. Now, and we know that if there is a sequence EI of different sets having measure will be finite for each value of I, then there exists one set O such that A is a subset of O, and outer measure of this O is less equal by outer measure of A plus some epsilon. As here outer measure of EI is finite for each value of I, so there exists an epsilon greater than 0, sorry, for epsilon greater than 0, and for all I there exists a sequence Aij whenever j running from 1 to infinity, such that each EI is a subset of union over I running from 1 to infinity Aij. That is, sorry, here j running from 1 to infinity Aij. Since each AI is a member of curly A, and EI is a subset of summation j running from 1 to infinity Aij, and as AI is subset of this one, then measure of this one is less equal by measure of this plus some epsilon, and Measure of this one is nothing but it is of the form summation j running from 1 to infinity a star of aij is less equal by mu star of ei plus some epsilon upon 2 raised to I. So here epsilon is a small quantity, then epsilon upon 2 raised to I is again a small. Okay, so summation j running from 1 to infinity mu star of aij is less equal by mu star of ei plus epsilon upon 2 raised to I. Now let us take the summation I running from 1 to infinity on both sides. Then we get summation I running from 1 to infinity to summation j running from 1 to infinity mu star of aij is less equal by summation I running from 1 to infinity mu star of ei plus summation I running from 1 to infinity epsilon upon 2 raised to I. But there is no term of I on in epsilon, therefore epsilon will be work as a constant, so which is nothing but summation I running from 1 to infinity mu star of ei plus epsilon into summation I running from 1 to infinity 1 upon 2 raised to. Tell me what is this sum? Summation I running from 1 to infinity 1 upon 2 raised to I. Value काय येते याची? वन अपॉन टू रेस टू आहे समेशन आय रनिंग फ्रॉम वन समेशन आय रनिंग फ्रॉम वन टू इन्फिनिटी वन अपॉन टू रेस टू आहे म्हणजे कसं असेल हे 1/2 प्लस 1/2 स्क्वेअर प्लस 1/2 क्यूब प्लस अप टू सो हे काय आहे कोणती सिरीज आहे कोणती ज्योमेट्रिक सिरीज माहिती आहे ना
येस सर
ज्योमेट्रिक सिरीज आहे का हे
येस सर
ज्योमेट्रिक सिरीज कशी असते ए प्लस ए आर स्क्वेअर प्लस ए आर क्यूब प्लस अप टू सो ऑन there are two types of geometric series there are finite terms then having formula will be a into 1 minus r raised to n divided by 1 minus r and if there are infinite number of terms then it is nothing but a divided by 1 minus r so where a is nothing but ये काय असतं त्यातलं फर्स्ट टर्म असते सिरीजची सिरीज बघितली नाही का हो तुम्ही ए प्लस ए आर स्क्वेअर प्लस काय असतं हे डिवाइडेड बाय 1 मायनस आर असतं ना जर फायनाइट असतील तर हे कुठेतरी ए टू दी पॉवर आर सॉरी ए इंटू आर टू दी पॉवर एन मायनस 1 ला थांबलं तर हे काय असतं ए इंटू 1 मायनस आर इज टू एन डिवाइडेड बाय 1 मायनस आर असतं ओके
येस सर
मग हे काय असतो यातला ए म्हणजे फर्स्ट टर्म आहे ना आर काय आहे कॉमन डिफरन्स आहे सो याच्यावरून याची फर्स्ट टर्म काय येईल या सिरीजची 1/2 डिवाइडेड बाय 1 मायनस कॉमन डिफरन्स काय आहे
1/2
आर इंटू आर आर स्क्वेअर होते ना मग 1/2 झाला ना तो 1 मायनस 1/2 1/2 डिवाइडेड बाय 1/2 1 येईल का
येस सर
okay so summation I running from 1 to infinity 1 upon 2 raised to I is nothing but 1 so which is equal to summation I running from 1 to infinity outer measure sorry mu star of ai plus epsilon so since this value is equal to 1 from this one so here we get summation I comma j running from 1 to infinity measure of aij is less equal by summation I running from 1 to infinity mu star of ei plus epsilon okay but e is nothing but union over I running from 1 to infinity ei okay and each ei is a subset of first write ei as each ei is a subset of union over j running from 1 to infinity aij which implies union over I running from 1 to infinity ei is again a subset of union over I comma j running from 1 to infinity aij. That is, it can be written as union over I running from 1 to infinity ei is a subset of union over ij running from 1 to infinity. So measure of this one obviously less equal by this one, but this one is nothing but e. Okay, so outer measure of union over I running from 1 to infinity ei is less equal by outer measure of union over I comma j running from 1 to infinity aij. Okay, so which is less equal by summation I comma j, which is running from 1 to infinity outer measure of aij. So finally here we get outer measure of this union over I running from 1 to infinity ei is less equal by this one. But out summation I comma j running from 1 to infinity outer measure of aij or this star, which is less equal by summation I running from 1 to infinity outer measure of ei plus epsilon. Just put their value in here. So we get outer measure of union over I running from 1 to infinity ei is less equal by mu star of ei, sorry, summation I running from 1 to infinity mu star of ei, maybe mu star of ei plus epsilon, but epsilon is arbitrary small, so take epsilon will be equal to 0. As epsilon is arbitrary, which implies mu star of union over I running from 1 to infinity ei is less equal by summation I running from 1 to infinity mu star of ei, and that is we have to prove. Then by the definition of outer measure, if it holds the three properties, if it is having measure will be equal to 0, measure of phi will be equal to 0, mu star is monotonic, and mu star holds, that is equal to union over I running from 1 to infinity ei, then mu star of t is less equal by summation I running from 1 to infinity mu star of ei, then we say that the corresponding function mu star, which is defined on power set of x, will be outer measure. So as if this function mu star holds all these three properties, then by definition of outer measure, the set function mu star is out. Mu star is the outer measure, and that is we have to put. Hence the required result. ओके, कुणाल काही डाऊट यामध्ये?
No, sir.